Hello guys. So today basically I have to check it's recording or not started. Yeah, it's started. So let's start our NLP discussion and today is the lecture second of NLP. So basically we will learn now TF-IDF vector. How TF-IDF work like term frequency inverse document frequency. So TF-IDF is good than one-hot encoding and bag of birds. So like how this is good then? Basically in there we have to create a one hot encoding vector or basically a sparse matrix, but it will not work fun because the semantic meaning is not captured and the sparsity is there like huge dimension it will create. So these are some problems which was solved by TF-IDF some extent but not at that much. So let's see how this will work. So term frequency, remember this word, term frequency inverse document frequency. We will come to that point. Suppose you have one sentence, one good boy, good girl, good boy, girl, good. So in that basically TF-IDF, if a bird is repeating many times, like good, good, good in is coming in every sentence. So we will give low priority to that bird. So, or a bird which is coming like basically is minimum time, then we will give high priority to that bird. Like we say, yeah, it's basically yes, these that is coming in every bird. There's nothing importance. Like this is a very simple bird. Like it is coming in every bird. It's not important. And if bird is coming sometimes, like then we will give high priority to that bird. Like we will, yeah, it's a very important bird. Suppose suppose for this in your family, your friend is coming every day, then you give not give high priority to that. If your friend is coming one or two times in your house, then you will serve some food and something like that. That's how this algorithm will work. So let's see a term frequency. Term frequency basically for let's see. Yeah, first we see the formula and then we will apply it. So memorize. We have to memorize this formula. Basically, you have to learn it. Basically, what happened? We have forgot this formula. So now I will explain how to remember this formula. So remember first you have to somebody say what is TF-IDF. Then you have to know the full form. TF means term frequency. IDF means inverse document frequency. So TF means term frequency. So term frequency means what is the frequency of that term. Term means basically bird. So what is the frequency of that bird in the sentence? So you have to now calculate the frequency or basically in the frequency of that word in the sentence. So the formula is number of repetition of word in sentence upon total number of words in sentence. So good is coming one time and the total number of words in the sentence one is two. So the term frequency of the good in sentence one is 1 by 2. And boys same also, right? Boys coming only one times and so 1 by 2. Suppose good boy good is used as sentence one, then the term frequency of good is 2 by 3, right? Two number of times good is coming in the sentence one. So that's how we will calculate the term frequency. So remember term frequency. So term frequency means the frequency of that bird or basically term in this sentence. Now coming to IDF. So term frequency will give you like the frequency of the inverse document frequency. Now inverse document frequency will help you to identify which word is repeating many more times. So if the word is coming in every sentence, this will give a lower weightage according to this formula. So this is formula log of e inside log of e like number of sentence like total number of sentence like this is opposite like inverse means now you have to total number of words upon divided by like in how many sentence good is present. So suppose good is present in three sentence, now you are finding the idf of this good. So the idf in like inverse document frequency of this good is log of Like total number of sentence 3 upon how many number of sentence there with the containing that word good. So 3. 3 by 3 is basically 1. So log of 1 is basically 0. So now this idea value will come for good is 0. That's how we will know that the good is coming in every sentence. So we don't have to give higher weightage to this good basically. If a bird is coming minimum number of times, then we have to give higher weightage. Like here we can see, suppose you have 100 sentence, so then 100 divided by in how many sentence it good is coming. Suppose good is coming in 3 sentences, so 100 divided by 3. And suppose now you have 100 sentence and good is coming in 50 sentence, then 100 divided by 50. So this how this will work. Like if you have a good is present in every sentence, then you will get automatically get a lower weightage. And if your number, like you have a total number of sentences 100 and number of sentences will, suppose your sentence will contain only one good and the total number of sentences is 100, then 100 divided by 1, like see how like huge value it is coming. Like that's how you have to calculate it. So for term frequency, you have to calculate for every word and every sentence, but idea like inverse document frequency will have to calculate for only that word. So and then we have to multiply it. So S1, suppose you have a S1, S2, S3 sentence there, and for S1, what is the term frequency of good? So it is 1 by 2, 1 by 2. We already know that in sentence 1, good is present 1 times and the length is 2, and boy is also same, and girl is 0 time present, and term 0 divided by 2 basically. And sentence 2 it is same, and sentence 3 is 1 by 3, 1 by 3, because every boy girl is coming one time, and total number of sentence like word is 3. And now we have to calculate inverse document frequency. Inverse document frequency I already told, like total number of words upon how many sentences that containing, like boy is containing 2 sentences and girl is also containing 2 sentences out of 3. So 3 sentences will have we have total, but 2 sentences will contain 2. So this is log 3 by 2. That's how we will this function will work. So final TF-IDF vector will be shown like this: sentence 1, sentence 2, sentence 3, good work, good girl. So you have to multiply this value with corresponding to this vector. So if you apply us in sentence 1 a good, sentence 1 a good 1 by 2, and apply a IDF value is 0. So something into 0, it will be a 0. That's how. So the good is automatically give a 0 weightage in every sentence, and boy is giving some weightage, and girl is also equal weightage because boy and girl coming same times, mm, two times. So basically we have given equal weightage. So that's how IDF will work. So basically the funda of this algorithm, if a number of suppose a bird is coming different times, mm, in every sentence, or we can say in every sentence, then we will give a lower weightage, and if it is coming in fewer sentence, then we will give higher weightage to it. This is basically a funda. Basically IDF term frequency will give you the term of that frequency, but IDF vector, basically IDF value basically will help us to find this like who is coming repeating money more times and who is coming lower times. That's IDF. TF-IDF will work. Now what is the advantage and disadvantage? So what is it is also intuitive. Basically we can see it's basically a simple formula is there. Now we have a fixed size vocab size. How? So basically here also we will create a sparse, not a sparse matrix. Basically we will give some weightage. Mm, let's come into this point. Basically, firstly we will discuss our disadvantage. Bird importance, yeah. So bird importance is getting captured. How basically this will capture like who is coming because of idea vector. Inverse document frequency will help us to capture which is coming most of the time and which is coming less number of times. So bird importance is also captured, and sparsity still exists. High sparsity is because of vocab size. Here we have fixed size of vocabulary. Basically, at the time of creating a TF-IDF vector, we have to say to our model like this is our output size. We want our TF-IDF vector in this size only. That's how this will work. And out of vocabulary is, it is also exist because at suppose a bird is not present at the time of training and it is coming in the testing, then out of vocabulary also exist. Only so now we have two advantage like sparsity and out of vocabulary. So this was solved by embedding, or we can say a bird embedding, or basically our bird to back. Bird to back also known as embeddings. So this is the advantage and disadvantage. So I think you will understand the TF-IDF. Now we'll discuss like how in advantage and disadvantage also, like intuitive, fixed size, vocab size. Like now this is fixed size. At the time of training, we have to define like this is our vocab size. But importance getting captured due to basically idea vector. Sparsity still exists out of vocabulary. These are some disadvantages. This was solved by our embeddings. So we will learn all of this like bird to back and embedding in the next lecture. That's it for today, guys. Let's meet in the next lecture. So now we will learn the bird embedding. Like we will see the definition and we will wind up the lecture for today. What is bird embedding? So in NLP, natural language processing, bird embedding is a term used for the representation of bird or for text analysis, typically in form of a real valued vector that encode the meaning of the bird such that the bird that are closer in vector space are expected to the similar in meaning. Now, I will explain all of this what they are saying. So bird in a simple manner, suppose bird, like I am talking now, I am teaching you something, I am telling, but computer can't understand this. So what they have done, firstly they have convert this bird into some vector so that our computer will understand. So that's we want, and we want so that I am talking this can be captured, like I am talking something. What, like suppose my name is Nasintangi and I, so like whom I am referring, so I is referring to Naren. So that's we want to capture all of this. So embedding will help us to capture all of these things. So how this will capture? So basically this will create a basically we can say, what we can say, a vector space, or we can say, yeah, vector space we can say. So inside this vector space basically there's some values to corresponding to. Suppose you are finding a embedding of a king, then this will be a embedding for king. There will be some vector spaces there, like what I have to give a value to the king, to the man and woman and royal and something like that. So if a king is there, then we have to give up a value to the man. Man is basically we are giving a man a value of 0.9, and the value will be ranges from -1 to 1 basically. So if we are giving a king value to a man a 0.9, then queen, then woman we will give a -0.9, and in queen will come, then we will give a negative value to the man, and woman give a higher like 0.9 value, something like that. And royal is there, then we have to give a again a value something like 0.8. It's something like that we will give a value so that our semantic meaning will be captured in a vector space basically. If you pass a vector in a king and queen, then there may be a similar like opposite words. So this will be captured by using a vector spaces there. Inside a vector space basically, for every word we will give us some different meanings. So at the time of training basically there's a pre-trained model and everything will be basically. Google have created this embedding and they have given some different value to every vectors. So if you have to create this embedding using a pre-trained model at the time of training. So this will help us to capture the semantic meaning basically. That's how it will work. Let's see all of these things in the next lecture. That's for today, guys. Thank you, guys. Meet in the next lecture. Okay, thank you, guys. Subscribe my channel again.